1.2 is solving absolute value inequalities. So yesterday we solved absolute value equations. Today we're just looking at the inequalities. Okay. So since we're working with inequalities now, we have to define some things. Remember, we have less than or equal to, and a word that I want you to start associating with that is and. And so the way that I remember less than is that and less than kind of sound the same. They have a little bit of the same sound to them. So less than, the word is and. Okay. When we graph less than or equal to inequalities, the graph is what we call the intersection of the two graphs. What's another word for intersection? A point, or like a street intersection, it's where two streets cross each other. So I'm just going to write a little note down there where the two cross. Okay. So we're going to have two graphs where they cross. That's our answer. And your graph is going to actually have no arrows. And when we do an example, you will see what I mean. We also have greater than or equal to, and the word that I want you to associate with that is or. And the way I remember that is great or. Okay, so if you have greater than or equal to, it's great or. Okay, for that one, the graph is the union. Now, what does union mean? Any guesses? Union means all of it put together, right? So for the union, it's everything put together. Okay, of the two graphs. So it's whatever the answer for one and the answer for the second put together. And for those, you will get two arrows. Okay, we do have two special inequalities that we have to pay attention to. Negatives with inequalities are a little bit different. If you have an absolute value greater than a negative, your answer is actually all real numbers, which means all numbers that exist. Okay, the way you make that symbol is two lines and then make an R out of them. Or you could just write all real numbers if you really wanted to. But the symbol is sometimes easier. So if you're greater than a negative, it's all real numbers. If you are less than a negative, your answer is going to be no solution. So this time, if you see a negative, it's not automatically going to be no solution. So with inequalities, you can have all reals or no solution. So you need to make sure you know which one's which. And then just a reminder, absolute value has two answers. Okay, so example 1. Example 1 says, solve for absolute value of y less than -4 and absolute value of y greater than -4. I'm leaving those special inequalities up there. See if you can tell me what the answer is. The first part, absolute value of y less than -4. No solution. Good. What about the second one? Absolute value of y greater than -4. All real numbers, or all reals. So that's all you have to put for your answer. Okay, there's no work to be done. We know it's a special case, so we can just go ahead and put that. So my point of doing this for you is showing you that we can go straight to one of our special cases. Okay. So write it down. Example 2. Solve and graph. Absolute value of y less than 4. Okay, now absolute value inequalities, a lot of the steps are very similar to equations, so we are going to actually set it up the same way. First of all, is my absolute value by itself? Yes, it is. So I can start breaking it apart. So this is going to be y less than 4. That's the original thing there. Now, this is less than. So is my word and or? And. So write in all caps right next to it and, because we're actually going to get two answers here. Okay? So with an equation, what did we do before? We said it equal to the positive and equal to the negative. So we know there's a -4 happening there somewhere. But what do you guys remember about inequalities? When you change it to a negative, what happens to this sign? It flips. So this is going to be y less than 4 and y greater than 4. Okay, so how do I know if they switch, if my word is and or? The word comes from what the original problem was. So I did write that as a note. And or comes from the original symbol. So the problem that they give you, that's where you're going to figure out if it's and or, the one that is given to you. Okay? So we have y less than 4 and y greater than -4. Because we changed the sign to negative, it had to flip. So then we can go on to graphing this. So now we're going to want to graph this inequality. So we're going to draw the number line. 0 goes in the middle. 1, 2, 3, 4, 5. -1, -2, 3, -4, -5. Okay. So since our answer here is y less than 4 and y greater than -4, because our word is and, we can actually combine these two inequalities into one. So our answer will actually be in the middle y is less than 4, and y is greater than -4. Now we can only write our answer like this when our word is and. So when our word is and, our answer is actually going to end up being one set of inequalities that looks like this. But to graph this, we are going to do it on the number line. Because we have less than and greater than here, there's no equal to. Our point is going to be an open circle. So at 4 and -4, we're going to put two open circles. So let's work with this one here. Y is less than 4. So that means that y is going to start at +4, and everything less than that is part of the answer. So it's actually going to be everything to the left, and it's going to go on forever. For the second one, y greater than -4, we do our open circle, and everything is bigger than -4. So everything's actually going to be moving to the right. Now that actually covers the entire number line. So let's go back up to the top and look and see at our definition. For the less than or equal to, where our word is and, our graph is the intersection, where the two cross. So there should be no arrows. So my answer is not going to be this on the outside. My y has to be between -4 and 4. So my answer is only this area in between the two. So I can erase all of that outside stuff, and my graph of the answer for this one is just what's between the -4 and the +4. So this is what I meant when I said up at the top that there's no arrows. Whenever your original inequality is less than and your word is and, you will never have arrows as your answer. It's always going to just be the end point and the area in between. Okay, so what happens when your symbol is a greater than? So let's look at example 3. For example 3, solve and graph the absolute value of x plus 2 greater than 5. So in this case, my absolute value is already by itself, so I'm going to split it up, x plus 2 greater than 5. And since my word is great, or my symbol is greater than, so it's greater, or my word is or. Okay, so my word is or here, And then when I break it up, x plus 2, we know that it's going to be a negative 5. And what happens when we change it to a negative? The symbol flips. So we have, our answer will be x plus 2 greater than 5 or x plus 2 less than negative 5. So let's solve for x. We subtract 2 from both sides. So we get x greater than 3 or x minus 2 less than negative 7. So since my word is or here, x is greater than 3 or x is less than negative 7, we can't combine them. So our answer is actually just going to stay like this with the word or in between. So if our word is and, we can combine them like we did in example 2. If our word is or, we have to keep them separated. But what does the graph look like? So I draw my number line again. I'm going to put 0 not in the middle, so we have 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, and I always go one more, negative 8. Okay, so let's graph this one first, x greater than 3. So I don't have an equal sign, so that one's also going to be an open circle at 3. And my x's are greater than 3, so they're going to be going to the right. Now for my second one, my x is less than negative 7. So it's an open circle again, and it's less than, so everything is going to the left. So in this case, my arrows are actually going in the two opposite directions. But does that make sense? Well, my answer says, or my definition at the top said, if I have greater than or equal to, the graph is the union of the two graphs, which meant we said we were putting everything together, and there's going to be two arrows. So when I look at example 3, and I see that my answer is x is greater than 3 or x is less than negative 7, it's okay that they're going in two different directions. My answer will either fall this way, greater than negative 3, or my answer can also be going this way, less than negative 7. So my graph is going to look like this with two arrows headed in opposite directions. And that's going to be the case anytime you see problems like this. So if your word is and, it's always going to be no arrows with your line in between the endpoints. If your word, and then your answer is one inequality put together. If your word is or, you're going to have two arrows going in opposite directions, and you have to keep your inequalities split up. And that will always be the case no matter what kind of problem you have. So, for example 3, we have solve and graph, negative 2 times 2x plus absolute value of 2x plus 4 greater than or equal to 12. Now I see the symbol is greater than or equal to, so automatically I'm thinking my word is going to be or. But if you notice, I have that negative 2 being multiplied on the outside. So let's see what happens when I divide first, because I can only get my word from whatever the equation or the inequality is after absolute value is by itself. So let's get that absolute value by itself. So I divide both sides by negative 2, because negative 2 divided by negative 2 gives me 1. So those are going to simplify. So on the left-hand side, I'm going to get the absolute value of 2x plus 4. Now when I divide by negative, my sign or my symbol always flips. So this greater than or equal to actually becomes a less than or equal to. 12 divided by negative 2 gives me negative 6. Okay, so now we have a negative involved. When I have a negative involved, that was one of my special cases. So let's go back and look at my special cases. I flip the paper over. If I have greater than a negative, my answer is all real numbers. If I have less than a negative, my answer is no solution. So what do I have here? In example number 4, we have everything is less than or equal to a negative. So I can stop there, and I know that there is no solution. So I am done with example 4. So then let's look at something a little more complicated at example number 5. I have solve and graph 2/3 times the absolute value of 2x minus 2 plus 4. All of that is greater than 12. So before I can tell if my word is and or, I need to get the absolute value by itself. So this 2/3 is being multiplied by the whole absolute value, but I first need to get rid of that plus 4. So I'm going to subtract 4 from both sides first. 4 minus 4 gives me 0, so those cancel. So I have 2/3 absolute value, 2x minus 2, greater than 12 minus 4 gives me 8. Now I don't quite have the absolute value by itself yet. I need to multiply by the reciprocal here, 3/2 on both sides. My 2's will reduce and my 3's will reduce, so I get absolute value of 2x minus 2 greater than 2 goes into 8 4 times, and 4 times 3 gives me 12, so greater than 12. So now I can look to see what my word is. I have absolute value by itself, greater than 12. So my word is going to be or. So when I take those absolute value bars down, I have 2x minus 2 greater than 12, or 2x minus 2 less than negative 12. Because I changed the sign to negative, the symbol changes to less than. So since I know my word is or, I know I'm not going to be able to put my answers together, so my answer will be 2 separate inequalities. But let's solve. I add 2 to both sides. So on this first one I get 2x greater than 14, or add 2 to both sides here, 2x less than negative 10. We're not quite done. We need to divide both sides by 2 on both equations. So we get x greater than 7, or x less than negative 5. So that's going to be my answer written out. Now I want to graph this. So on my number line, and I'm going to put it up here, I need to make myself some, make sure I have enough room. So this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, so I know that my word is or, so I'm already expecting to have 2 arrows going in opposite directions. So my first one is x greater than 7. So there's no equal to underneath there, so it's going to be an open dot at 7. Greater than means I'm going to the right. The next part is x less than negative 5. So I know I have an open dot at negative 5, and since it's less than, I'm going to be going to the left. So I have 2 arrows going in opposite directions, so that's what the graph of this one looks like. Last one, example 6. I have solve and graph 5 minus 6 times the absolute value of x over 2 minus 1 greater than negative 1. So I see that I have greater than, so I'm thinking right off the bat my word might be or, but I also see this negative 1, which is a special case. But I don't have the absolute value by itself yet, so I can't for sure say it's going to be a special case. So let's get rid of that, or get the absolute value by itself first. So I have this 5 here that's being added onto the outside. This negative 6 is actually being multiplied. So I need to get rid of the 5 first. So I'm going to subtract 5 from both sides. Those 5s are going to turn into 0. and I'll be left with negative 6 times the absolute value of x over 2 minus 1 greater than negative 6. Okay, we still don't have absolute value by itself yet, so let's divide both sides by negative 6. Those negative 6's are going to reduce to 1. So I will have the absolute value of x over 2 minus 1. Now, since I divided by a negative, this greater than symbol is going to flip to less than. Negative 6 divided by negative 6 is positive 1. So now I don't have a special case anymore. So that's why it's very important for us to get the absolute value by itself before we stop doing anything. So my new symbol now is less than, so I know my word is going to be and, so I'm going to write that right away. And since my word is and, I know that my two inequalities are going to combine into one. So let's split it up first. We have x over 2 minus 1 less than 1, and x over 2 minus 1 greater than negative 1. So to get x by itself, I need to add 1 to both sides. So that gives me x over 2, those 1's turn into 0, less than 1 plus 1 gives me 2, and when I add 1 here, I get x over 2 greater than negative 1 plus 1 is 0. So now I need to get x by itself, I need to multiply both sides by 2. So those 2's will reduce to 1, so I get x less than 4 and multiply by 2, x greater than 0 times 2 is 0. So I can combine these into 1. So that's x in the middle. X is less than 4 and it's greater than 0. So that's going to be my answer, all is 1 inequality. So let's graph it. Since my answer is 1 inequality and my word is and, I know that there's not going to be any arrows at all. Let's do 0, 1, 2, 3. There's not going to be any arrows at all, and I'm just going to have my endpoints, and the space in between is my answer. So I have open points again, and I have 1 at 0, 1 at 4, and my answer is the stuff in between. Okay, so as a recap, when I'm graphing, if after I get absolute value by itself, my symbol is less than or equal to, my word is and that means that my graph is going to be the intersection or where the two graphs cross. So my number line will look something like this. I'll have my number line, I'll have my 2 points, I'll make them closed on this example, and my answer is somewhere in between the two. Okay. If you have one that says greater than or equal to, your word is or. The graph is the union of the two graphs, which means you're going to have 2 arrows. So on your answer, you will have your points somewhere here, and your arrows will be going in opposite directions. So your answer will look something like that. When you write your answer out in algebraic terms, since this one is in between, you can put your x or your y in between. Since this one is not, and the 2 lines are separated, you have to keep them separated. We never want to forget our special cases. If we have an absolute value greater than a negative, your answer is all real numbers. And if you have an absolute value less than a negative, it's no solution.